In this video, we're going to complete the state functions. Now, with everything we've done, we've set this up really well so that our state functions should actually be quite simple and easy to manage and to write. We've got all our states set up, so we've divided it nicely. So when we're in the wait state, we only have to worry about what we do in the wait state. When we're in the attack state, we only have to worry about the attack state, and so on. We've also got our helper functions that we've written down the bottom. So this chunk here should really just be the algorithm, your actual approach and your strategy that you've written in your state diagram. So let's start filling it in. So basically what we're doing is we're just writing the code that does exactly what these comments here say. So the first thing it says is if an enemy is in the danger zone. So let's do that. Let's say if, and we've got a helper function there, enemy in danger zone. So if we call that function, that'll return true if there is an enemy in the danger zone, and false if there is not an enemy in the danger zone. So that's really all we have to do to check if an enemy is in the danger zone. Now if that is true, it says change to the attack state. So we'll say self.current state equals the state attack. And that's that section done. That was easy. So if that was true, would change to attack, but if it's not true, then we want to continue on with our code. Now we don't want to run this code if that was true, so we need to put inside an else, an elif in this case, because we're going to ask another question. So if there's an enemy in the danger zone, do that, else if, in this time we're going to check if a teammate is in jail. So again, we have a helper function for that, so we'll say self teammate in jail. So if that is the case, we're going to change to the jailbreak state. Current state equals state dot jailbreak. Okay, and that's that section done. And the very last thing is we'll put in an else. So if those first two things weren't true, if they were both false, then we'll go on to the else, which is turn towards the closest enemy. So we need to get what the closest enemy is. So I'll get a variable here, enemy, and again we have a helper function that takes care of that. So we'll call closest enemy, and so now we know which enemy is the closest, and we'll say self dot turn towards, and as you can see up here, I have to give it an X position, a Y position, and a speed. Speed's optional. If I don't put the speed in, it'll be slow. So you can see up there speed equals slow. That means that's the default if I don't give it one. So we need an X and a Y, so we'll use the enemy that we discovered is the closest enemy, the enemy's X position, and the enemy's Y position. And I'll set this one to globals.fast. So we're just going to turn towards the closest enemy, and our turn will do it as fast as we can. And that's it. That's the wait state done. Because we've put all that work in there already before we got to this stage, the actual state function itself is very, very simple. In fact, you can read it just like you can read the comments. If self.enemy in danger zone, then switch to attack. Else, if self.teammate in jail, switch to the jailbreak state. Otherwise, if those two aren't true, then find out what the closest enemy is and turn towards it. So that's as simple as it is for wait. So let's continue on and look at the attack. So the first line there, check if there is enemy in the danger zone. So we know we can do that because we've got a helper function, self.enemy in danger zone. If there's an enemy in the danger zone, if not, change to the return state. So this time we're not checking if there is, we're checking if there's not. So I'll put a not in the front of that. So if not self.enemy in the danger zone, then in that case we want to change our current state to the return state. Now we don't have anything else to check, so we don't need an elif, we can just do an else. So if the first one isn't run, then this one will be. Turn towards the closest enemy and drive forward. So first of all, we'll grab the closest enemy. So I'll create this variable and say self.closest enemy. So a helper function will take care of that. It'll grab the closest enemy. Then we need to turn towards it. So self.turn towards enemies dot X position, enemies dot Y position, and I'll do that for a fast speed. Now you might be thinking, oh, we seem to be putting fast into everything, why wouldn't we just always do fast? Well, as your bots get a little more sophisticated, if you want to do a small turning circle, so that means you want to turn quicker, then you want to turn fast but move forward slow, and you actually turn in a much smaller turning circle. So there's times where you do want to turn medium or slow, but that will all depend on your strategy, and you probably do it when your bots become a little more complicated. But then again with this state here, you can see it's very simple. 1, 2, 3, 4, 5 lines of code. They're all very simple, and then that's that one done. So this is the way I would suggest that you do your state machines. Your actual logic should be very much just like the comments. So your code in these states should be very, very simple. If you find yourself writing a whole bunch of code in here, think very strongly about moving that out into a separate function, so that when you look at this, you can see, okay, is my logic correct? Is my logic exactly what my priority finite state diagram says it should be? And if you don't put all the implementation, like enemy in the danger zone, if I had all the code in here that checked if there was an enemy in the danger zone, this suddenly wouldn't be as readable. Okay, so there's two reasons to break things out into separate functions. That is if it's used in multiple places, so you're not repeating the code, and if you get a chunk of complicated code in here, you want to move that out as well, so that your actual state code is as simple as what we're seeing here. So this is very, very straightforward. So we did all the hard work to begin with. We set out the states, we set out the helper functions. Now you can see this is actually very, very simple once we actually get to this point. So let's do the jailbreak again. If an enemy is in the danger zone, so we'll say, okay, self.enemy in danger zone. If that is true, what are we going to do? Set the current state to attack. Okay, so we've done that comment. And you can see how easy it is. I'm simply just reading the comments and implementing it in code. Check if a teammate is in jail. Okay, if self.teammate in jail. Now the next line says if there isn't. Okay, so we'll put not at the front. If not self teammate in jail, because we said if there isn't, not if there is. Then we want to change to the return state. So self.current state equals state.return. And that should be an else if. We only want to do this if the first one didn't run. And then the last thing, else, we do our final action, which is turn towards the jail and drive forward. Okay, so I'll go self.turn towards. Now because I'm the blue, I know I need to go into the top left hand corner. So for the moment, I'm just going to put a couple of numbers in there. I'll say 50 pixels for the X, so 50 across and 50 down. That'll take me up into that jail area. So I'm happy with that. Self.turn towards 50, 50. Now if I was the red and I want to go is jail, it's the bottom right hand corner. So I would say for the X it would be screen width minus 50 and screen height minus 50. So that would take me to the bottom right hand corner. But in this case I want to go to the top left hand corner. So the 0, 0 is top left hand corner and it goes out from there. So I've now turned towards the jail area, and now I'm going to drive forward. And I'll put in a speed. We may as well just go with fast again. It's only a very basic bot, so we don't have to do anything clever. We'll just do everything at full speed. And that's jailbreak done. Again, very simple code. What's that? 7 lines of code, and one of them is just a single word else. So again, that's very simple. We're just implementing what we've written here. We've already started this one. If an enemy is in the danger zone, so self enemy in danger zone, change to the attack, which we've done. Okay, so if I come up to the next one, check if a teammate is in jail. Okay, so if self.teammate in jail, so you can see these helper functions are really, really helpful now. If that is the case, then change our state to the jailbreak state. So I'll say self.current state equals state.jailbreak. Okay, again, made the mistake of putting an if there. It should be an else if, because we only want to do this check only if this first if isn't run. We don't want to do it if it is run. And then we've got another thing to check here, so we'll do another elif. Check if current position is range of the home location. Okay, so here's an important one. When we're going back to the home location, you don't want to aim for a single pixel, because the bot could be approaching it and just miss it by a pixel, and then it goes and does a big circle to come back, and it just misses it by a pixel again. So what you want to do is just say, I'm somewhere near the home location. Okay, so if we're, say, within, I don't know, let's go with 50 pixels. If we're within 50 pixels of where we want to be in the home position, that's good enough. Okay, so what we'll do is I'll do a point-to-point check, point-to-point distance, and I'll do it on self.x, self.y, so my current bot's position, and I'm going to see what that distance is between there and the home position. So the home position, I will put, for this particular bot, I'll say the home position is 50 pixels in front of the red flag. In front of the red flag, which is the flag we're defending. So I'll say globals.redflag.x and globals.redflag.y. Okay. So then I just want to check if that distance is less than 50 pixels. In that case, it means I have got to the home position or near enough to the home position. So when I'm within 50 pixels of the spot I want to be, I'll say that's good enough. I'll now change to the wait state. So current state equals state, wait state. Alright, again, because if I'm aiming for a single pixel, it's going to be very hard to hit that exactly, and I might continually miss it and just circle around it all the time. I just want to say if I'm near enough to that spot, that'll do. Switch to the wait state. Okay, and then the final thing here, I'll say else, and then do the action, which is turn towards the home position and drive forward. So as I said, our home position, I didn't quite do that right. I'll go back up here. We want to be in the same Y position as the red flag, but we want to be in front of it, so we'll say plus 50 pixels. Okay, so we need to be in front of it, and I might change the tolerance a little bit and say, okay, we need to be within 20 pixels. Okay, so the home position will be the red flag's X position plus 50, so just out in front of the red flag, but at the same height. Alright, so now that's exactly where we want to drive towards as well. So we'll say self.turn towards, and we can basically just copy this bit of code here, because that's where we want to aim for. Okay, so we'll turn towards that spot and self.drive forward, and we'll go with the globals fast again. Okay, and at this point we've implemented an entire defense bot that has jailbreaking as well. So when you get to the end here, it looks like a lot, looks quite complicated, but in actual fact, if you break it down, it's very, very simple. We've listed our different states. We determine what state we're in every tick, and we call the function that's associated with that. Our functions should read just like our comments, which I think they do because we've used helper functions as well and kept this section just to the logic of what the bot's actually doing when it's in this state. And then down the bottom we've got our helper functions that do some of the hard work, do a bit of work that gets repeated in different states, or if it's just complicated code, we'll drop it down here. So when you're working within a function, you only have to worry about what that function is doing. That's a really nice way of breaking up our code, making it really modular and making it really easy to follow. So I can look at any one of these states. This is the most complicated state, the return home, and I can just see, is each section doing what it's supposed to do? The comment will match our priority finite state diagram, and then the code should match the comment. And if it does, then that's good, that's all working. Now maybe enemy in danger zone isn't working, but when we go and do that, we don't have to worry about anything else other than is this function effectively finding if an enemy is in the danger zone. So it makes our code much, much more maintainable. Now that's a basic defense bot. It is very basic. When you design yours, you're going to have to think about other things you can do, how you can more effectively defend. So let's say you've got a few enemy bots coming in. You don't want all your defense bots just going for the closest one. If one is going for the closest one, then maybe the next one goes for the next closest one. And so that's where you extend your priority finite diagram. But as long as you translate your priority finite state diagram into code using this approach, then you'll always keep your code manageable. Because believe me, it will get out of control really quickly if you do not have some sort of methodology and approach to make sure you keep it simple like this. The other thing I would say is you don't turn around and write an entire bot like I just did before you actually run it. In reality, if I was developing this bot, I'd probably do this top section where I'd set all the states and I'd set the tick, but then I would implement just one. I'd implement one of them and I'd test it. And I'd test to see if it works as much as I can, and then I'd implement the next one. And then I'd test to see if that works. And you'd iteratively, slowly go through and build the whole bot, checking it as you go. Nobody turns around and writes a whole block of code, hits go, and it works flawlessly. Okay, so it's best to test everything as you're moving along. So I think that's it for now. Good luck with your bots, and all the best with the competition.